Alright, in this video we're going to start talking about how to evaluate trig with inverse trig. So what that means is how to evaluate things like cosine of the inverse sine of 11 over 12, things like that. And the way we do this, it actually depends on quite a lot of things. Depends on are these functions, is it cosine and inverse cosine, or is it cosine and inverse something else? Is the inverse function on the inside or is it on the outside? Are they nice numbers on the unit circle, or are they not nice numbers on the unit circle? So there are a lot of things that we have to consider. So what we're going to do is use this flowchart here. And if you want a copy of this flowchart to follow along with, check the video description. For this video and for the next several examples, we're going to be using this flowchart. And actually what we're going to do is, in this video and over the next several videos, we're going to do at least one example of every possible path here that we can follow in the flowchart. So let's zoom in a little bit and look at the flowchart. So if you're not sure how to read a flowchart, it's actually very easy. Just start up here, start at the starting point, and then we just ask ourselves the question, and then we answer the questions, and then follow the flowchart based on our answers. So when we look at a problem, we ask ourselves, is there a domain violation? If there is, there's no solution. If there's not, go down to the next step. Is the function paired with its own inverse? If it is yes, then follow the yes branch and check this stuff here. Is the function paired with its own inverse? No. If not, follow the no branch, do all the stuff down here. Okay. So there's a lot more branches down here. It might seem kind of confusing, kind of like a big headache. There's a lot of stuff going on here. It's really not that bad. Once you get more practice, it'll actually be easier to identify what type of problem each branch leads to. So anyway, let's instead of going through the whole flowchart here in this one video, what we're going to do is go through just little pieces at a time over the next several videos. So what we're going to do in this video is do two examples of the simplest type. So let's zoom out a little more. So example 1. Let's say we want to evaluate tangent of the inverse sine of, because I don't really need that, tangent of the inverse sine of 12. Okay. Tangent of the inverse sine of 12. So we go to our flowchart. So okay, so it's a trig and inverse trig problem. Here's a trig function with an inverse trig function problem. So it's trig with inverse trig. So we go to our flowchart and we say, okay, is there a domain violation? And yes, actually there is. There is one. Okay? Because we cannot take the inverse sine of 12. Remember, the domain of the inverse sine function is from -1 to 1, like that. So whenever you take the inverse sine of something, it has to be between -1 and 1. So inverse sine of 12, we just can't do. It's not possible, there's just no solution, or it does not exist. So is there a domain violation? Yes, there is. So the answer is no solution. Okay. So no solution. Or does not exist, DNE, etc., etc. Okay. How about example 2? Example 2 is, let's say we want to evaluate inverse cosecant of the secant of pi over 2. Okay. So the answer is probably not going to come as any surprise here based on what we've been talking about and what we're doing, but so it's inverse trig with trig, okay, trig with inverse trig here, and then secant of pi over 2. Can we do that? No, we can't, right? Pi over 2 is actually not in the domain of the secant function, so we cannot do secant of pi over 2, because remember, secant of pi over 2 is 1 divided by the cosine of pi over 2. And cosine of pi over 2 is 0, so that's actually 1 divided by 0, which is just totally not, just no, can't do that, no, bad, very bad. Okay, so pi over 2 is not in the domain of the secant function, so is there a domain violation? Yes, there is. So the answer would be no solution. Okay, okay, so that's also the answer for example 2. And we'll do some more examples of some of the other branches in the next few videos. And I promise it does get a little more complicated, a little more challenging, but it's really not too bad. It really doesn't get that bad. Okay, so that's two examples of trig with inverse trig, and a little flowchart here for how to do these types of problems. More examples and more paths on the flowchart coming up in the next few videos.